Good afternoon, everybody. Welcome to my talk about Protractor, generators, and Co. How many of you have been using Protractor in the past? Quite a few. Wow, I'm impressed. Well, claps to you. Applause to you. Yeah, we need to get the energies going. And how many of you have been using ECMAScript generators? OK, that's more than I expected. So you are an awesome audience, and I'm going to quickly take a selfie with you. So I will have this memory. Yeah. Will be tweeted sometime. So now, after I learned about you, it's your turn to learn about me. So who am I? Why am I speaking to you? My name is Uri. I'm an AngularJS and web technologies Google developer expert. I also love robotics, electronics. I build stuff. That's a Raspberry Pi over there. And then I also dance salsa. And I also play the Peruvian pan flute, like. Thank you. And one final point, I work part-time for BlackBerry. They still exist. So that was a little introduction about me. And after we know who I am, let's see our agenda for today. So the first thing we are going to talk about is Bluetooth. The first thing we are going to talk about is Protractor flows, and see why they are flowed for some use cases. Then we are going to get to know ES6 generators. I know that many of you are not familiar with them, so you'll get a nice introduction to them. And finally, we are going to see how we can combine those to make our Protractor tests much more user-friendly. Do you all test your code? Yeah, I see everybody nodding. So I know that you love to test your code. And that's why you do it on production. So today we will be testing a cat rating application. It's called TopCat, and it has nice pictures of a kitten from Flickr, which you can upvote and downvote. Now, as I just mentioned, the best way to test your application is to take it into production and call it beta. So this application is built using AngularJS and Firebase as the backend. And I uploaded it to Firebase hosting, so you can all play with it during the talk. You are invited to open this URL and start rating the cats that are waiting for you just there. And as soon as we get some stuff about generators done, I will show you the results. So come in, even if you are, whether you are here in the audience or watching the live stream, and go to topcat.firebaseapp.com and start casting your votes. So now we are going to switch to a new slide, and it's going to be about Protractor. So I will go through this really quick because most of you already know Protractor. When I write end-to-end tests with Protractor, they are usually run inside a Node.js. They are always run inside a Node.js process, which communicates using a WebDriver with your browser. So your apps runs in the browser. The tests are run inside Node.js. And let's see a very simple test scenario in Protractor. So this is a simple test scenario. And you can see that it performs two operations. They are marked in blue. And when you get to point A, that point in the code, an inexperienced developer would probably have expected the browser to have been opened and this assertion to have been executed. But what really happens behind the scenes, when we get to point A, nothing has happened yet. Protractor maintains a queue. It calls this the execution queue. And this queue contains all the operations that we requested. So when we get to point A, the queue will contain those 2 lines, and they will only be executed asynchronously after this function finishes running. Now, this is a really nice abstraction, in my opinion, because you don't have to think about async code when you are writing your end-to-end test. Or perhaps, do you? What happens when you have a database and you want to talk to the database during your E2E test? See some of the people nodding like it happened to you already. So in this case, we will have to tap into the async queue of Protractor and add our code inside a function, just like this. So we need to wrap our code in browser.call that will put it into the queue. And then we have to deal with promises and all of that stuff. So the asynchronous abstraction of Protractor starts to break down as soon as we need to talk with a database to do some HTTP request, and it's not awesome. Fortunately, with ES6, we have a new feature called generators. These are not human generators. These are new kind of generators, and we are going to see them in action in a moment. And what they give you is infinite power. So what are those ES6 generators? This is a generator. So you can see this nice star next to the function name. This star tells the JavaScript that we want to create a generator. And then you can see the yield function. So the yield keyword. So what this code does, generators can return multiple values. They return values using the yield keyword, and they can also be paused and resumed. So I can have multiple statements in a single generator, and it can be paused between those statements, those yield statements. Before we see that, I also want to say that generators are available now if you are using Android, or you have Chrome, or you are using, is anybody here using Node.js? I guess yes. Yeah, I'm using. So if you are using Node 4.0 or newer, they are there, they are available by default. You don't have to do anything to take advantage of them. So the first generator we are going to see is, of course, a meme generator. We all love Doggy, which says smart things like that's JavaScript or very generators. So this is an example of a simple generator that returns 2 values. The first one is returned using yield. Yield the string such generators, and then we also return another string that says very generators. And when we call this generator, when we call this function here, it actually doesn't immediately start executing. What actually happens, we get an object which has a method called next. Whenever we call next, the generator starts executing and stop at the next yield statement. So when we call the next for the first time, we get the first value that was yielded to us. And then when we call it for the second time, we will get this wow on our console because the function will resume executing directly after at the point where it was stopped. And then it will give us the return value, which is very generators. So whenever we write a generator, it will stop on every yield. It will return to the control to the calling code, to the outside code. And whenever we call next, the control is returned to the generator, and the generator continues executing. Now, this is one aspect of generators. The other aspect is, well, you probably see this code on the screen, and you think, like, I can connect to that. We'll go over it really step by step. So this is an advanced Doggy meme generator, and it has 3 different prefixes. each time it gets a word, and it appends one of the prefixes to the word. So when we call doggy with the string Angular, nothing happens. It is not executed yet. The generator is created, it's returned to us, but the code is not yet executed. Once we invoke the first call to next, the code starts executing until the first yield, which happens to be here inside this loop. So in this case, we'll take the first prefix, which is such, and the word that was given to us as a parameter, which is Angular, and it will return to us such Angular. Then the function stops executing in this yield statement. And here comes the nice features of generators. Whenever we get something from the generator, we can give it something back. So in this case, we give it the next word, the word speed. When we invoke the second next function, we can specify a parameter, and this parameter will be returned from the yield statement. So it lets us communicate with the generator. We can get values while it's executing, and we can pass values in. And whenever yield is called, the execution stops until the next method is invoked again. So the second time we get here speed, word will be set to speed, the loop will iterate again, and we'll get vary and speed, which is the return value of the second next call. Another thing, just to keep the picture in your mind complete, instead of calling next, we can also call throw. We will not use it in this session, but you can also call throw if you wanted to throw an exception inside the generator. So instead of having yield return a value, it will just throw an exception. So we can either resume the generator, or we can throw an exception if something bad happens. Now, why should you care? The answer is promises. Once we have promises, we can really simplify our code by combining them with generators. How does that work? I'm going to show you in a second. So we said that generators can be paused. What if whenever we had a promise in our function, we just paused it, and then we resumed it once the promise resolved? We can do that with generators. Let's consider the following example. We all love Bitcoins. And here is a really simple piece of code that fetches the current, does an API call to fetch the current Bitcoin value, and using then, it prints it to get a console. Using generators, we can rewrite the same function with just 2 lines of code and with no dance or thinking about promises. All we have to do is whenever we get some promise, we need to put the yield keyword. So the generator stops, wait for that promise, and then it resumes executing whenever the promise is resolved or rejected. But I bet this looks like a bit magic to you. I mean, how does this work? I mean, I just said that you need to invoke the next method and do all of that stuff. So this doesn't work out of the box. Fortunately, I have a small demo for you, which is exactly the same code. Let's make the font a little larger. Yeah. So here we have the same function. And then what we do, we call it, which creates a generator. And we take the first value that the generator yields, which is this $HTTP.get. And we store it in a variable called promise. Then we say, whenever this promise is resolved, go back to the generator and resume it with the result of the promise. So what actually happens, we will perform this HTTP request. And whenever the HTTP request, after we call it, we yield the promise, the execution will stop And whenever this piece of code, this promise is resolved, the generator will resume from the same point. We will get a result in R, and we'll be able to print the value of the Bitcoin. So let's figure out how much is Bitcoin. Is anyone here invested in Bitcoins? No? I bet you don't. So now we can see that the value of Bitcoin is 269. And I bet you are all thinking to yourself, like, you could have bought it at $2 like 3 years ago. And you are also probably thinking to yourself, OK, so this piece of code is cool, but man, I have to write all of this code to execute a generator. So doesn't it defeat the purpose? And the answer is, you don't have to write. There is a library called Co. And what Co does, it does all of the wrapping your function, accepting the promises that you yield to it, waiting for them, and resuming your code whenever those promises resolve. So it's more advanced version of what we have just showed in the demo. And of course, it's open source. So if we go back to our last demo, we can rewrite the same code with Co and replace all of this promise handling with just a single call to Co. So we have here the same generator, and we simply invoke it with Co, and Co will make sure that whenever we yield any kind of promise, the execution will stop, and it will resume with the value of the resolved promise. And then you will have all those demos available on GitHub. You'll be able to experiment with them and see what happens when you call yield multiple times, whenever the promise, your promise is rejected, how the exception is being thrown inside the generator. So with that in mind, we have Co. There are also, and it works on Node.js and on browser. And as I said before, you have all the generator functionality already available for you in Node and inside the browser, so there is no need to install. You don't need transpilers, or as Shai said, transpilers. You don't need them. You can just use this in plain browser and plain Node. And finally, if you don't like the name Co for some reason, or you want to explore some alternatives, you can use Bluebird's promise.co routine or another library called task.js that does exactly the same thing. So we have seen Co, we have seen generators. It's been a lot of content in a really short time. And now let's see how we can combine that to test our Topcat application with Protractor, generators, and Co. So we have this nice Topcat application. We'll see the vote results in a few minutes. But first of all, let's have a quick look at the main controller for the app. It's quite short. All it does is connect to Firebase. And then once the data has been loaded, it sets some variable to true. So later in the test, we can wait for that condition to happen, for all the data to have been loaded. And then we have the like and the unlike button. So we have two functions for them. The like adds 1 vote for the cat. The unlike takes away 1 vote. And they both save it to Firebase. If you are not familiar with this Firebase syntax, don't worry. There is another session that goes concurrently, so you probably missed it. It's recorded, but good point, by Sarah Robinson from Firebase, where she talks about Firebase and Angular 2. This is the main controller. The only thing that we need to pay attention to is that we set VM.ready to true once everything is ready, once all the data has been loaded. And then let's go directly to the test spec for this application using Co and ES6 generators. So we can make the font a little larger. Yeah, I knew I would do it. We have here this function that sets up everything before the tests. And what it basically does, first of all, it puts the mock data in our database. So we have this gets variable, which contains some mock data for our tests. And as you can see, it just calls http.put, which is a library that resembles Angular's $HTTP. And this one returns a promise. Now, we use yield to yield that promise. And as you can see, I have to wrap all my functions with code.wrap, which adds the generator promise handling. So whenever I want to use this technique in Protractor, I need to wrap my functions, either before each or the actual test specifications, with code.wrap. And then once I'm here in this line, I know that the data has already been saved to my database because I know that this yield posed the function and it was resumed as the http.put promise resolved. And then I call browser.get to get the main page of the application. And again, I yield it to co, which will wait for the promise to resolve and resume this code only after this page has been loaded in the browser. Finally, I'm going to look for the topcat container, which contains all my cats. And then I'm going to use a little-known feature of Protractor called EC, is actually expected conditions. Thanks. Andres told me about this last night, so it really helped me to make my test shorter. So thank you, Andres. So I'm waiting for the presence of this topcat container. And again, I'm using yield, so the function will stop until this element is displayed on the screen. And finally, I'm calling another function Andres has just told me about, evaluate, to read the vm.ready variable from the scope of the application. So here we set vm.ready to true in the application. And then evaluate allows me to read some value from the scope of the element of that element. So I'm waiting until vm.ready returns true. And of course, I'm using yield. So this function will actually only terminate only after all of those lines have been executed. And if any of them fails, it will, of course, throw an exception and fail the test. And then I use exactly the same technique in my actual tests. So let's see the second one, which is more interesting. We have here a function that tests the upvote button. So I will reformat the code to make it look a little more readable. And what I do, I wrap my test specification with code.wrap again, and it's a generator. And as you can see, I'm calling here yield after I click the button. So this line will find the thumbs up button for the first get, and it will click on it, and it will wait until after the button has been clicked. And then I perform an HTTP request and query the database. So this is the ID of the first cat. I have this URL hard-coded. I perform a GET request against Firebase's JSON API. And once this yield statement return, it will return me the value of the JSON object that represents that cat. And then I just check the votes and make sure there are 5. In my test data set, this cat has 4 votes, so once I upvote it, it gets 5. So as you can see, this looks more or less like synchronous code, but it's totally asynchronous. You get full flow control. You can put here breakpoints if you debug your code. And since it's running Node understands generators, breakpoint will work correctly. And we have some magic here, but it's much more explicit, since whenever we wait for something, we don't just add everything into a queue, as we have seen in the beginning, and hope that things will be executed in the right order, which usually does not happen. We actually stop our code whenever we need to wait for something and resume it as soon as we got that thing. So we have only 16 seconds to view the results. I think that would be enough. First of all, I see that somebody has managed to update this application. So congratulations to the Firebase hacker that put some string inside my vote numbers. But I think this one rocks. And then I see here we have Uri Goldstein. That's amazing. Well, I love your community. You rock. You. Well, thank you, everybody. And before we go, you have a summary. You will read it at home. And then you have here the link to the slides. You can copy it, and it has a few more links to some very useful resources about generators, about the technique I told you about, and of course, the Topcat demo in GitHub. So, thank you. You have been a great audience.
Thanks, Yuri.